So this question is saying that you have to find the set of all values of t belonging to real number for which the matrix is invertible, right? So a matrix is invertible when the determinant is not equal to 0, right? So the value of the determinant of this matrix should not be 0, okay? Then the matrix is invertible, right? So if I try to find out the value of the determinant, I can see that this is common in all the three rows, and this e to the power minus t is common here, this e to the power minus is common here, okay? So I can take out e to the power t, e to the power minus t, and another e to the power minus t out from there, and then I'll be left with the remaining things, right? That is 1, 1, 1 in the first column, sine t minus 2 cos t, 2 sine t plus cos t, and cos t here. Here I'll get 2 sine t minus cos t, sine t minus 2 cos t, and sine t here, right? So obviously this thing here is combined. If I just multiply them, I'm going to get e to the power negative t. E to the power negative t cannot be 0, right? So obviously if there is a chance this can be 0, e to the power negative t cannot be 0 for any value of t, right? To simplify this determinant, I'll do two row operations. I'll say R1 goes to R1 minus R3, and R2 goes to R2 minus R3. Okay, so that means I'm subtracting the third row from the first and the second row basically. Okay, so what I'll get is, if I do these operations one after the other, I'm going to get this becomes 0, this becomes 0, this is 1, because I'm subtracting the third row from the first two rows. Okay, and here I will get sine t minus 3 cos t. Here it will be 2 sine t, here it will be cos t, minus 3 sine t here, minus cos t, negative 2 cos t, sine t here. Okay, this should not be 0. Okay, we have to find such values of t, right? And since we have two zeros here, so I have to only expand about this one. After expanding, what will be left is this thing here. This is, if I write it here, is going to be negative 2 cos t multiplied by, so this into this minus this into this basically, minus 2 cos t sin t minus 3 cos t plus 2 sin t, 3 sin t plus cos t. Okay, so this simplifies to negative 2 sin t cos t plus 6 cos square t plus 6 sin square t plus 2 sin t cos t, right? So these two cancel here, and 6 cos square t plus 6 sin square t is simply 6, right? So these two is 6 only, right? So the value of the determinant is coming out to be, this was there already, e to the power negative t and into 6. So this is the value of determinant. This is not equal to 0 for any real value of t, right? This is not equal to 0. This matrix is going to be invertible for all the real values of t, because this cannot be 0 for any value of t. Hence option number 4 here becomes the answer. Okay, thank you.